Okay, so welcome everyone. My name is Sylwia. I am a Haskell developer at Luna, which is our local Kraków startup. And today I will tell you a few things about Luna. So first, why have we started this? We know that if we think about our world, the data science is the future. We have more and more and more data, and we want to process them. And our business people want to get the insights from the data we are gathering, but it is not that simple. So why am I saying this? If you look at the top 10 emerging positions according to LinkedIn, we have their machine learning engineers, data scientists, big data developers, and directors of data science, and full stack developers, and all of these people need to work with the data. And if you look at the market, you can see the same. Harvard Business Review told us that data scientist is like the sexiest job of the 21st century. If you think about the market is growing incredibly. Like we have 500,000 positions and less than 200,000 people to fill them. The average salary is quite high. There is a lot of job openings. So maybe everyone should do the data science. But what it takes to do the real great data science project? It is not that easy because you need to have the coding skills, and most of you have them. You need to understand math and statistics. It's fine. Like we have physicists and mathematicians, they can do all the crazy statistical stuff. But also, you need to get the domain knowledge and the business knowledge. And to do all of these things, we need to communicate or teach the people who are like experts in business how to code, how to write, how to analyze things. So we have some tools we can use. We can write the data science using Python or use C++ and TensorFlow to do great machine learning models. Why not? We can use R. R is like quite simple to learn. It will be fine, isn't it? But all of these tools have their problems. The cognitive aspects are like a real struggle for the people who are not that technical. So if you will get, let's say, the experimental physicist and show him a modeling part of this experiment, like the Python code, which will not be like the biggest part and the most complicated. It will be just like few thousands of lines. He will get lost like at the first moment. So we can use the programmers to create the software and then give the software to the people who are like the domain experts. So let's think about this. I will ask one of you to write the analysis for the market with some model. Then you will give the results for the domain expert, which will be the analyst in the bank. And next time when the analyst wanted to change anything, he will go back to you and ask, okay, we did their standard deviation, but now I want to get their like the same ×2 or something like this. It is a little bit annoying to like go back and forward between the domain experts and the developers. So what we can do to make it easier? We can create better visualization for this. We can draw a diagram and write the greatest documentation ever. How many of you actually write the greatest documentation ever and write the diagrams for your programs? Our hero. But it is not that popular. And here comes Luna. What is really Luna? Luna is a general purpose programming language with a visual representation. What does it mean? Does it mean that we have the code and we can visualize it, like make a graph? Or maybe we are taking just the blocks and connecting them and create a program. Neither or both, as you wish. So Luna has a dual representation. What does it mean? Here, I don't know if you can see it well, I hope so. So here is Luna Studio. Luna has a node editor and a text editor. If you will add a node in the node editor, probably, can I? So probably this way. Yay, thank you. So yeah, we have added a node to the node editor, so we got the line in the text editor. If you will add now a text in text editor, you will get the node. So the dual representation means that you can either work with the graph or with the text. And it is like, at the same time, really the same things. The question is also, I need to, no? Yeah. The question is also, is it compiled or interpreted? So because you are building the graph, you have the inherently dynamic computation and interpretation going on. So what it really gives you? Well, you can get the clear levels of abstractions because you are putting the nodes, and on each node you have the single thing going on. You can see the data because we are focusing on data processing, so you can see how the data are changing during the flow and get the insights on each step. It is making the communication much easier, like really, really easier, because on each step, the domain knowledge expert or other developer can see what is really happening. How you can work with Luna. I will do the maximization part. Yeah. So here I will show the short film, how you can build the graph from scratch. This is the real-time visualization for Kraków trams on a map. So let's start. Luna can work with data from many, many different sources. This is like API for TTS Kraków.pl. If you want to start working with Luna, you are just pressing the tab. When you are pressing the tab, you are getting the searcher. Searcher is there to guide you and to show how you can start to work. So we have got the address, and now we want to get the JSON. If you see, under each node, you will have the visualization. So the JSON is the object, which has last update and a list of vehicles. If you look at the vehicles, you can see that there is a lot of empty IDs in this collection, empty objects. So not all of the trams are existing there. But if we are scrolling like long enough, we will get to the real part. If we want to get just the existing riding trams, we need to filter them if they have or not the longitude. And what really happened just now? We can select few nodes and collapse them into one, so we can refactor it and create a single function from them. And now we can get just the head for this list and create the visualization. If we look at the longitude and latitude, we can see that this is like 7.19 10 to 7, so it is way too big. We need to refactor it. to get the real longitude and latitude for Kraków. And we can again get the ID and the name. Put them all to one JSON and show on a map. Yeah, so we got the idea pop-up content, and we can create JSON. So GeoPoint. If we have done this for the single tram, we want to now reuse this function to do it for all the trams we have on a list. So we can again collapse the functions, delete the head function, which was taking just the first vehicle, and do the same for each tram. But I was talking about the real-time visualization. So the same can be done every 3 seconds in the easiest way. Yeah. Okay. So this is how you can work with Luna. Of course, this will produce the full code, and you can commit it, you can refactor it, everything. And what kind of benefits do we have from this? Well, we can see that it improves our correctness and productivity because we have visualizations under each node. So if anything will fail, or you will do anything wrong, you will get like a wrong point on the map. So it will be easy to see what is happening. Because of the graph, we have the clear pipeline for everything. So if you want to show just a part of your program, like you have someone with the domain knowledge and the engineer from machine learning part, the engineer can build the model, collapse it into one node, and you can show just the output as a single node to the domain expert. You don't have to show him like the details of the model. So it is improving the communication, because if you don't have thousands lines of code in your program, it is easier to show what is happening. And it is really easy to start with. Why? Because you are just pressing the tab and choosing the function. And on the next step, again pressing the tab, it will help you to choose the right function to work with your data on or with your previous node. Some technical details. So Luna is purely functional, with laziness language, with immutable memory. We have the node, and the node is like the thing which starts everything. So single node is a single function or a single line in the code. You have the types. If you hover over the node, it will show you that the input for this read function will be the text, which will be the file path, and the output will be a table. So we have a static typing, but types are here just to help, because we want to make it as easy as it is possible to work with Luna. You don't have to think about the types until you really, really need them. So if you're starting, you are not typing like table read will take the text and output the table. You don't have to do this. You don't have to think about this. But because you have the static typing, you can see that our searcher is giving you a hint, which will be better for you because searcher knows that you have the table here. So probably you want to do aggregation or a column or add a column to your table. Let's talk a little bit about the type system. In Luna, we have algebraic data types. What does it mean? It means that you can construct more sophisticated types from the simple one. As you can see here, on the left side, it will be Luna. On the right side, it will be Haskell. Okay. So here we have a simple sum type, which is constructed from foo_int a and bar a list a. What we have there? We have parametric polymorphism. What does it mean? So you can have the type foo_a, which will, you can say that this function will work for the a's, which will be int and real and stuff like this. You have the pattern matching. So if you see the function bus, which will take foo, which will be the type foo_int and return foo_int, you can say, okay, so in case of foo, where foo is foo x y, it will add 1 to x. And if it will be bar x, y, s, it will add to the first x, 1. And of course, multiple value constructors, as you can see. So how this will look like for Luna? We can have, again, class foo, and the function bus, which will get the foo with the pattern matching, like for Haskell here, and multiple value constructors. So it is really, really similar to Haskell. But what is like painful in Haskell is getting the object properties. Like if you want to get just the names, if you look at this class name home type and class name mobile, we have the name for home and the mobile, which will be the text. And you want to access just the names for all of them. In Haskell, you will have to write, first you can't have name for name home and name mobile. So you will have to write the class getName, where the name will be a to text, and then write 2 instances, or the instance for each, to select the name and tell, okay, instance getName for name home, where name is home name. It's really long, and if you're introducing someone new to this type of programming, it is like really annoying. So what have we done to make it easier? In Luna, you can have the class work with the field name and the class mobile with the field name. And moreover, you can get any random class which will have the function name inside. And you can write just, I want to have a function getName which will take the name for each of them. And then you can construct work Johnny and 12, where Johnny will be the name, and mobile sum with random string where name will be sum, and then the random class, and use just getName on all of them and print it, and then you will get Johnny, Sam, and such a name on all of this. You don't have to think about the instances. It is just really easy. So how about computational effects? In Luna, we have laziness. So if you don't force the program, it will not evaluate the things you don't want. So the data types don't force their fields. So in this case, if you print foo, it will not print anything. Functions don't force their arguments. If x is less than 7, then print foo, else print bar. Does it print anything? How do you think? Or how many times? Then it will, yeah. So if x will be like 5, it will print just once the foo. And if it won't be top level, it won't, like, at most it will print once. But it is easy to force evaluation. So if you will get the lazy data type like just print Luna, you can force it saying get to print it. About lazy function arguments, you can have const 12 with the second argument, which is lazy about the second argument, so it won't print anything, but you can use the function which will be strict about first argument like sec. I'm sorry. To force program to be strict. And the great example, lazy versus strict, is a list. You can have lazy mapping on a list using the map, which will return just a list of things, or you can evaluate each print. Okay, so that was a little bit about the language, like the data types and laziness. And what about the libraries? Because this is like the first thing everyone is asking. Because we are really young language, we have bindings to C++, Python, and JS at the beginning. And Luna really, really loves Python. So we have started with bindings to scikit-learn and Seaborn and Matplotlib. Well, yeah, maybe later. For sure later. And how about the things you can do in Luna? This is the example flow for Luna for prediction. Okay, from the beginning. The data is the single stock data, which you can use to predict and forecast the market. So you can build the bot who will tell you that you should sell or buy the actions by simple analysis created from scratch. This is the technical indicator called Bollinger Band. And you can, from scratch, also create the visualization for it. So it is like really useful for the people who don't know like how to program, but want to construct something from scratch. You can use it to analyze the insurance prices. These are the prices for the insurance in US, dependent on if you are smoking or not. You can also easily get the insights from the data before like the actual result, the last part, to see, okay, this is the smoking person and this is the distribution age versus charges, to get like next knowledge. And this is like, oh, okay, the dark flow is not the best. Here we can connect to the Postgres and get this flow, like 1, 2, 3, 4, 5 nodes, connecting to the Postgres and filtering just the Italian restaurants in New York. And it is really, really easy. And great thing is about this is that if you don't show the visualizations, you are evaluating everything on the last node. So it is quite fast. Because this is the general purpose language, we can use with any library you want. So here we have OpenCV and the face recognition flow in Luna, actually. So where are we with the project? We have open sourced GPL, MIT. Yeah. So then we had the better performance release in August, I think. We are working on new GUI because, okay, the language itself, the backend part is written in Haskell. The front-end part is partially Haskell, partially JS, and we are just improving it. Why would we improve, and in what's like, what is the direction for the graphical user interface? We want to make it more clickable, like better for really entrance user, make more like widgets to control flow and stuff like this. And we are working on libraries. Our main focus now is the data frames library. We have based it on Apache Arrow to make the work with R and Julia and Python the best. And you can, where you can find us? On GitHub, where you have access to everything. There is our website, where is the button for the chat, where we are like almost always, and the forum. Do you have questions? Yay. We have, well, first we have the contributors who are like, there is a group from Warsaw University of Technology who is doing the TensorFlow collection. I was talking last week with the other group from Warsaw University of Technology they are doing the library to compare the machine learning models, and they want to do more interactively, so they have started with R. Then they went to Python, but doing it in Luna will be like much easier. There are few people, like few banks we are talking to make proof of concepts. There are people from the community building stuff around, like actively. Yeah.
That were shown were rather easy. The one with just presenting terms on there, it was rather straightforward program. What is the biggest program written in Luna? Because if there will be much business logic, I see those graphs would grow enormously.
I don't know about the biggest program in Luna, probably. Okay. Yes. I can give you like the other microphone, probably.
So I have one web scraping project that's about 5K lines at this point. And as for the graphs growing like uncontrollably and not being readable, that's not true. That's not the case with Luna, because we have the notion of abstraction. So the moment when Sylwia has shown you how to select a bunch of nodes and collapse them into a single function, that's basically a refactoring. So if you have like 100 nodes on the stage, that compares to having 100 lines of code in a function, which is a bad thing, and you refactor as you go.
Dragging the mouse, like definitely the visual part is easier. You don't have to drag the connections or like remember what to type. You can just put the node and then connect the inputs. It is like much easier. Of course, there are people who will not be, they don't want to learn how to use the mouse and do the graph. They want just to code, so you have the code for this. Now it is better. Like at the first release, it was like hard to work with. Now it is like comfortable to work with for me, at least.
For you, for users,
we have
nothing about programming
we had like last week the workshop with the people from the bank, and there were people like, okay, the lady was older than us and was never using any programming language, was analyst using SAS. And she managed to build the flow and work with it. She had some struggles like with the zooming and panning sometimes because like she is different user than we are used to, but it was like really easier. She told us actually that it was easier to for her easier to work with this when she got the flow and started, and she was not so convinced before when she was just looking at the demos.
Okay, so I have a question. I have a problem with being clear sometimes, but I'll try, because there is a bunch of research on programming languages, on usability of programming languages, on all the stuff, how people perceive data, how people understand what they see, and how people are able, how much data we can really understand when we see them. So I just wanted to know, because you are. And there are people like Brett Victor or other guys building a lot of programming systems that are trying to be visual, and for some reason there has not yet been a successful general programming system, like visual programming system. There are things like Max for Ableton, but this is like very specialized with graphs. So is your idea based on any research? Like what was the reason to start that? To even go this way? Was it like just fancy idea, or was it like research and papers that that prove that it may be a good idea to go this way?
So it's not based on research, it's based on experience. The idea was born when my co-founder was working with Side Effects Houdini, which is a node-based system for 3D graphics, and this system has huge successes in visual effects. So and pretty much most of the languages, they have successes in their respective fields. So there's LabVIEW for electronics, there's Max for sound processing, and so on. As for the general purpose effort, I'm not aware of any actual effort to make that happen. And that's because most of the languages, or they are not even languages, most of the visual systems, they focus on a bunch of different nodes for the most common operations, and that's pretty much all you get. So we have focused on making it an actual programming language where the textual representation proves that it's as good as any other language, while the visual representation is there to help, which means it's. Usually when you have those visual systems, you have a bunch of programmers that create new blocks, and you have a bunch of users that only combine them. With this, we can actually bootstrap and put both groups in both roles, meaning that it can actually scale with the community. You can have analysts that even unknowingly create something that's library worthy, and that they can publish whatever they create. So this is where we believe we are different, being an actual language. So removing the boundary between the say IT support staff that is creating the nodes and the users that are using them.
And I assume you believe that is, because I'm not sure about that, but I assume you believe that is a good idea to allow more people to program, because for me it's sometimes good programming is hard, because sometimes it should be hard.
Okay, but
if you see what I mean, like sometimes some tasks should take much time and much thinking,
but it is not. It is not about like. Sometimes you want to teach people, and you want to get rid of this barrier of doing totally new stuff. Like the analyst should know how to build the model, including the machine learning. Why wouldn't he? Like, why you want to take it away from him?
I think programming is more just because Luna, in this case, is replacing syntax of the language. It's just replacing visual textual representation to the visual representation. And programming is, I think, something more, because this is rather thinking in abstraction level. So just replace. I think if data scientists would like to just do all the stuff we can see there, probably the language isn't, which is textual, not graphical, is not the biggest obstacle for that. I don't know if I'm right with that, but I think.
Why?
No.
Like, I think like there is like.
No.
Can I take this one?
Yes.
So this is kind of contrary to what we learned talking to people. And yes, programming is about abstraction, and I think you are underestimating the level of abstraction that non-programmers possess. And as an anecdotal example of semi-programming that will probably get me kicked out of here is Microsoft Excel. I have met people at different large organizations that have huge Excel spreadsheets with a bunch of different sheets, all interconnected, at which level they are basically programming. They are able to comprehend all the abstraction. At the same time, a file with even 100 lines of code is so intimidating to them that they cannot wrap their heads around it. Moreover, functional programming proves very efficient here, because if you think about Microsoft Excel and tools like that, it's all about transforming the data and not about thinking in terms of memory cells. So we basically believe that serving programming in a much more approachable manner makes it more accessible to people, and it's not the problem of the abstraction level or the intellectual capabilities of the users. It's the problem with the obscure syntax that we are basically struggling with since the 70s. So this is why we believe it needs to change.
Thank you.
How about having UI in JavaScript where I see your face?
So that's why we are moving to WebGL.
Also based on JavaScript. Yeah, it's like we don't have a choice, but most of the business logic in our graphical interface is also written in Haskell and transpiled to JS, just because of that. So. We did, but back when we started, it was not mature enough to do that.
Okay, so I have a different question. How does a case expression look like as a graph?
I don't think I have one here.
It's not visualized yet. That's the simple answer. The more complex answer is that basically a case node is just a collection of lambdas, like a collection of functions, and each function is going to be visualized as a subgraph. So basically a box that has some inputs, some outputs.
Okay, thank you.
Yeah.
Is making the output of it committable a goal? Because with graphical interfaces,
You have this. Like, actually, you have. I need to show you something like the code. You have the real code with metadata, which you can just commit, and you can actually write the pure code in any other code editor, like, I don't know, Visual Studio, your favorite, anything you want. The difference will be just that we will have to auto lay out the nodes instead of like remembering where you put them.
okay, and where do you say the layout of data? It's with the code? Or
It is with the code. It is with the code. I will show you like the actual code. Probably. If you see this is like you have, you don't have the, yeah, so I don't have here the code with the metadata, but the metadata are like at the end of the file where you can store them.
it's a block, it's a big block at the end.
Yes.
Okay.
Plus the markers on each line.
Okay. Is the block like split in lines somehow, or is it just?
No, this is like one.
It's not. It's a huge JSON object, and if you have an idea for how to make that diffable and like less painful, please share. Like this is something that we definitely need to do some more thinking on. Right now the huge object at the end of the file is not really mergeable. So that's one of the problems that we are facing with that representation. Basically, if you are putting that through Git, you have no trouble with merging the actual logic. There will be some trouble with merging the visual information.
It's good knowing that you think about it.
Yeah. Any other questions?
Well, I have maybe one more.
Yeah.
So it's a different topic. You at the same time decided to create a new language and a new editor for this new language. Why not just use Haskell?
Have you ever seen Haskell? Yeah, so that's why. No, to be more serious, Haskell is just scary. Like the syntax of the language, even though the concepts are very simple, like at least to some extent, the syntax is just too scary to present to newcomers.
That's not an exaggeration.
Yeah.
Fair enough, I guess.
Okay, so thank you very much.